Very good morning to one and all present here. It gives me the immense pleasure of inviting you all for our AICTE sponsored 6-day online short-term training program on secured data optimization in IoT using a GNU radio companion and USRP. So I wholeheartedly welcome our today's chief guest, Dr. S. Lakshmi, Educational Research Officer and Associate Professor, B.V. Raju Institution of Technology, Vishnu Educational Development and Innovation Center. We welcome and I welcome the staffers who have participated from the state colleges, and we have planned this slot as a 6-day slot from 16 to 21 is the first slot, and 14-12 to 19-12 is the second slot, and in 2021 18-1 to 23-1 is the third slot. So this is a AICTE sponsored program. So I wholeheartedly thank Professor Dr. Vasantaraj for getting a fund from AICTE, and he is successfully organizing this program for the benefit of the teaching community to enrich their knowledge in the field of experts. We have started our short-term training program, and this is the first day. So we have scheduled for 6 days as a slot 1, and various resource persons is going to handle, and they are going to share their ideas. So I insist all our faculty members and external participants, please join hand with us throughout the program and make use of this program in future. And I will tell the short biography of our department. So our Department of ECE was started in the year of 2007 with the intake of 60, and it is elevated to the higher intake of 120 in the year of 2012. And the same we have got the PG program in applied electronics intake of 80. So 16 we got a NAC B plus grade, and 2018 we got a NBA for our program, and 2020 we got a NAC A plus grade, and the same year 2020 we have elevated to the autonomous status. So at present 400 students are pursuing degree in our program. So we have got so many funds, research fund, and especially we are having a research center for our department. Totally 40 scholars are pursuing a PhD under our research department. So once again I extend a warm welcome to the dignitaries who are from various colleges, and I am going to thank our faculty members, organizers of this program, for the successful conduction of this program throughout the slots. Thank you one and all. I hand over to the Dr. Vasantaraj.
Thank you very much, sir, for a wonderful welcome address. Is it audible?
Yes, sir. You are audible, sir.
So now I welcome Dr. K. Bomaraja sir, Principal Excel Engineering College and Executive Director for Excel Group of Institution to deliver the inaugural address to our participants.
Hello, good morning. Hello. Can you able to hear me? Hello. Hello.
Yes, sir. Good morning. Yes, sir. Yes, sir. Good morning, sir.
Okay. Audio is clear. I think little lately I joined. Okay, anyway. So very happy to join in the session, inaugural session of AICTE sponsored online short-term training program on secure optimization in IoT using GNU Radio Companion USRP. So on behalf of management, directors of various portfolios, HODs, and my own behalf, and people who have joined here, to on everybody's behalf, I welcome all the gatherings who have assembled here for very good interactive session that has been organized by Department of Electronics and Communication Engineering. At this juncture, I will also thank, in addition to welcoming all of you, I would like to thank the AICTE for giving us a provision of conducting this program for 6 days. And not only these programs, few other programs have been sanctioned by AICTE for the short-term training program for the benefit of faculty members who are all registered for the respective programs. So it's a nice occasion that right period and right occasion that this kind of programs are being organized by departments of ECE, and topic which they have chosen is it's once again a very important topic which will benefit the people who are working in wireless communication and various other areas, software defined radios or wireless communication, other segment of discussions, even the security point of view, some of the topics what they have covered. I think really it is going to be helpful for participants to get into the things. I think today we have nearly, I don't know how many participants are there, and I think more, maybe more than 50 participants across maybe our faculty members and faculties of other institutions, and even a few of the 16 only. I could able to see very minimum participants. 16 probably they will join. I believe that few more faculty members and students will join this session. So today we have with us Dr. S. Lakshmi. I think Madam has already joined. I could able to see the presentation. And Madam, thanks for joining with us. And today we have other experts also today. We have Vetrivelan Pandu, and we have Dr. S. Udaya Kumar, and Dr. T.P. Anita Sri, and Dr. V. Balaji, and Dr. S. Shankara Gomati. Today we have this session with which will be conducted or which will be presented by various experts. So this kind of STTP nowadays it has been conducted in online. Of course, lot of programs already our Department of ECE conducted for the benefit of our own faculty members and faculty members of our region. I really appreciate the faculty members of ECE and particularly the HOD of ECE, Dr. Anbu Karabsamy, for taking enormous effort in coordinating with the people and bringing the experts like today who have been, we are invited like this, lot of experts agreed us invitation and wholeheartedly presenting the recent scenarios which are happening not only in such a domain what today we have selected, otherwise VLSI, embedded, lot of different domains we have arranged. I think that's really a wonderful gesture shown by the faculty members in this pandemic situation where they are taking so many effort in bringing the expert together and organizing for the benefit of faculty members. Only thing is that the faculty members of our own institution or the participant who join here really make use of this such opportunities and get benefit out of that. Doesn't mean that being there for quite some time and listening to the experts what they say without involving themselves is not the right attitude. Probably when a program, such programs are being organized wholeheartedly, everybody should get participate and get benefit out of that. And once again, I thank all the organizers for inviting me for this inaugural session. All the very best for the successful conduct of these events for next few days of time. And participants, please interact with each other, get to understand each other, and please form a group in this particular domain so that in future also we can interact for the benefit of our own development for pursuing our research publication kind of thing. All the very best and thanks for the opportunity. Over to the MOZ, please take care.
Thank you, sir. Thank you very much, sir. To give you very good inaugural address, sir. And I will tell you about the welcome address to chief person, that is speaker, Dr. is currently designated as an education research officer at Vishnu Education Development and Innovation Center, and short term we can call as VEDIC, run by Sri Vishnu Education Society, Hyderabad. Has conducted many workshops, quality initiative, improvement in quality improvement in higher education, and also interested in more educational trends. And his PhD research his work is investigations on behavior analysis for improving learning practices. And the primary objective of research work is to build a student model for the intelligent tutoring system based on biopsychological potential. Degree from Anna University in May 2017 under the supervision of Dr. Rajiv Sukumar, IIT Madras. She obtained the Master of Technology in Computer Cognition Technology with distinction from University of Mysore and Bachelor of Engineering in Computer Science and Technology from VRS College of Engineering, Madras University. So spanning over 19 years, started from humble beginnings as software instructor in computer across located in a remote town. She has the experience as a lecturer at Mahendra Engineering College and second state in the Krishna College, Coimbatore, the senior lecturer at Banariam Institute of Technology, Coimbatore, and then later promoted as assistant professor in Dr. NGP Institute of Technology, Coimbatore. She had also joined Aditya Institute of Technology, Coimbatore as assistant professor, which she had been promoted to the role of associate professor CSE and HOD of CSE, ITP, and associate professor Department of Information Technology at AIMS Institute of Higher Education, Bangalore. Had the wonderful interest, which have the core expertise in theory of computation and use of ICT in teaching theory of computation, and faculty development programs, and have been covered 25,000 to 30,000 faculty members, including TQI, SERB, SWAYAM, DST, ACT, MHRD, attended workshops, and she has been a jury for many national conferences and national student symposium. She has published 16 international conferences and 15 international papers and 5 patents professionally published. Have the built a software model based on biophysical, psychological potential, cognitive test, brain dominance, learning style preference, multiple intelligence, and personality. So it's named as software is named as KYC, Know Your Caliber. So the area of expertise of the madam is educational research methodologies, IQAC, curriculum planning, learning assessment, improving learning using cognitive psychology-based assessment, accreditation, and expertise in interactive video material creation as well as in video editing. I welcome you, madam, to deliver your speech. Up to you, ma'am. Thank you, ma'am.
Thank you, sir. Thank you, Executive Director and EC HOD and the organizer and the coordinator of this sponsored workshop and all the faculty members of EC Department Excel Institute. I am happy to say that twice I visited your institution when I was in Coimbatore as an external examiner for the laboratory examination. Twice, 2 different semesters. I have seen your institution as well. So the person who has seen your institution, I am associated with you today. I am so delighted and thank you everyone. And I welcome all the participants and dignitaries and distinguished invitees of this AICTE sponsored workshop. Today, I'm glad with you all to share an overview about Internet of Things, IoT. So today there is no specific scope we will be having to discuss deeper. It's all about breadth. So what are all the layers, or what are all the domains and interdisciplinary, multidisciplinary, what we need to touch upon? That is what I'm here to address about. Hope so my presentation is visible. My first slide is on Internet of Things and overview. I would like any one of you please acknowledge me. My audio is comfortable and my
Yes. Yes, sir. It's clear. It is clear. Thank you.
so much. Yeah. So this is what we are going to address today. The holistic picture. Then it has different layers, different functionalities. Then each and every other session will be towards the deeper discussion. It's a vertical discussion. Today, the first session, I would like to touch upon the breadth of the domain called IoT, because many participants, you may be joined today, very new to IoT also, you may be intermediate level, or you may be advanced learner, whatsoever may be, we need to moderate the things. That is the reason we are interested to touch upon an overview today. I would like to say that IoT is a perfect example for both interdisciplinary kind of project, we can say, domain we can say, or multidisciplinary kind of domain we can say. This is what the perfect combination works out for both of terminology called interdisciplinary as well as multidisciplinary domain. So with that, how I do say this is interdisciplinary and multidisciplinary domain, let us short discussing in a couple of slides, after a couple of slides. So now I would like to know from the chat window, may know who is this person. Any clue you can communicate in the chat window. Similarly, anybody attends through YouTube channel, they can communicate in the respective chat window. I would like to know at least a couple of response. Who is this? If you have idea, I'll give 1 minute. You can give the name of the personality. If I give you a text, you will get a clue. Google will support you. But now I have displayed an image. So you may need to go for image recognition. Only then Google will support you. Yeah, that's fine. So the person is Kevin Ashton. He is father of IoT. He is a person coined the terminology called Internet of Things and the basics or foundation. He is the person have brought this arena. He have not contributed too much, but the idea, initiation, the breakthrough, innovation, called the domain Internet of Things, brought by Kevin. So this is the first thing we may need to start with gratitude. We may need to start thanking all the inventor. So that is the reason we want to start with him. Subsequently, this is the person. We all should feel proud of being Indian. Such kind of eminent scientists we do have. Dr. Arogya Swami Palraj, he is of person from India, especially Tamil Nadu. He born near Pollachi. He have brought the reformation or innovativeness towards high-speed Wi-Fi and 4G technology. He has a person, or he is a person introduced this technology 4G. Right now we are all enjoying with our own Geo, Airtel, 4G technology. Right now things are moving towards 5G. The moment 5G is exist into the picture, immediately industry 4.0 or 4.0, all other revolution will start keep moving towards the rapid fast manner. That is for sure. So now things are waiting, or things are in the developmental stage, or in the prototype stage, or test bed, whatever the way we want, we can say. Because of the 5G technology only, we are waiting for all those things to happen, to become true. There are country already it is taking place, but more or less people are waiting for 5G technology. Now, I would like to start with one small activity. Even the participants, those who are attending in the YouTube also can take part. The thing is, two commonly used processor, or any processor which is required for IoT applications definition, are at the end, what I say is crisp information about IoT, whatever you know, you need to put it in this activity in the form of text information. Maximum it will permit 100 characters. So if you want to contribute to multiple, then you need to use 2 different messages to this activity. Finally, it will create one word cloud. So through that, I could able to understand what are all the perspectives, levels, or the depth of participants who are all taking part in this activity. So right now I will move on to that particular scenario. So this is what the particular activity I wanted to give you a brief. It will have one QR code. You need to just use your QR code scanner. If you have in your mobile code scanner, you can scan it. If not, there is a slido.com. There is a website will come, then it will ask you to enter the code. If you enter code, then you can get connected with this activity. Then immediately you can start responding whatever the idea or the definition or the familiarity with application or processor names which are all used for IoT, any perspectives, broad picture I'm giving. So you can start typing your answers or contribution. So with that, we can spend for another 5 minutes. This is a good amount of thing I wanted to spend with you all to understand. Slido.com is the website. So with that, I will start moving on. Now I will stop this sharing of screen. Is it visible? Join at slido.com. That screen is visible. I request any one of you to kindly acknowledge me. There is a screen. Otherwise, I need to stop the screen and I need to start sharing this. Okay, I'll change now. One minute. Is this visible now? You please, there are 2 different ways. You can scan this QR one way. Let us start quickly. Share your crisp answer regarding IoT. This is what I have kept the title of this activity. Or else you can log into slido.com. Then it will ask you to enter the code. You may need to enter this code. Then either way you can participate into it. Then you may need to give your answer within 100 characters. So crisp answer, you are permitted to give multiple answer. However, you need to give crisp answer. Anything which you know about IoT, a bulletin word or a buzzword or any familiar application, you can start posting right now. So this is what I wanted to conduct for next 5 minutes in order to understand your proficiency. That's it. So that will give you a clue to where I need to move forward fastly, where I need to spend some time, where idea I will have. That is the reason I wanted to conduct. You please take part. Let me know if you find any difficulty. You can use chat window or anything. So this is the QR code. You can directly scan with the smart mobile application if you have. If not, you can move with this one, slido.com, www.slido.com. Then you can enter this code. This pin, the moment you enter, you will be joining this event. Please contribute. I think not even single one have joined. Why is that? Let me know if there is any difficulty also. Please make use of the chat window. I'm not sure how many participants are here as well as in the YouTube. Directly you can scan on my screen using your mobile. Or else you can use this website www.slido.com and you can enter this pin in order to join with this activity. It's too late. At least by this time, 1 or 2 members would have joined. Yeah, very good. Someone joined. Thank you for your contribution. IoT has got applications, agriculture, traffic monitoring. Very good. If you wish to give multiple answers, you can give. If not, you please help others also to join here. Thank you. One contribution have arrived to this platform. Similarly, I would like to know about others' thought as well. You can even leave the Google, I guess. You can scan and you can take part in this and you can come back and join the session after 5 minutes. Let me know if there is any difficulty. If not, please join as early as possible. Contribute your answers. Anything which you know, the processor which are all useful for the IoT development and application, name of the processor or any hardware, name of the sensor. I'm giving you a bigger perspective or spectrum. You can contribute in any way. Share your crisp answer regarding IoT. It's a very general and vague question only. There is no specific. So for now, only one member have joined into this activity and contributed as well. Let me know at least from the chat window if there is any difficulty. There are 18 members, at least 8 members. If you join here, that would be good. Sir, is YouTube is also telecasted, sir? I request any one of the host or moderator to support me. Is YouTube is also telecasted?
Yes, ma'am. YouTube is also now it's telecast going on.
Ma'am, is there anyone finding difficulty with that, joining this activity from the YouTube? Let me know.
Okay, ma'am. I'll ask and inform.
Yeah, ma'am.
Okay, ma'am.
Then at the end
Okay.
of the session also, I wanted to take it forward their questions if they post there. All
Okay,
sensor
ma'am. Sure,
interconnected.
ma'am.
Yes, thank you, ma'am. All
Okay,
sensor
sure, ma'am.
interconnected. Yeah, interconnected through IoT. Yet another answer. Fantastic. One is towards application. One is towards the architecture. There are 2 members have contributed. Thank you for your contribution. Just you need to scan this QR or you can join through this URL www.slido.com with this. Yeah, if not, I thought you would be enthusiastically participating. There is no enthusiasm I could see as of now. The reason may be 2 things. Either you are not able to get connected through this activity or you are not interested. That's it. Okay, still I'll keep it open, then I'll start changing. I'll move towards the presentation. I think it will lead a lot of wastage in time. Let me cover. Yeah. Now I would like to ask one more question. What is this product? If you only half a minute, I can give timing, or you can unmute. You can even use audio note also. If you wish to communicate in the audio note, could you able to see this product and understand what is all about this product? If you, any one of you know a clue about this product is also sufficient. I request you to take part in the chat window if you know about this product. Either name of the product or whatever you know about this product, the story behind of this product, anything if you know, you please communicate. If not, let me proceed. Okay, so from why I'm asking question, not to trouble you, just I wanted to make you to become aware of, just you need to be alert mode, you need to be in the learning mode. The need arises anyone to learn. So you need to think there is a need to understand this concept, need to know this terminology. The need arises. So only 2 slides I will question, rest all no more question, don't worry of it. So this is the product. Shark Tank is one of the American business reality television series. Netflix, you can participate. You know about this Shark Tank American business reality television. So this event, what it will do is anyone, either you and me, anyone can go and present our product, innovation, idea, or the complete product, anything, a prototype, a design, utility model, anything we can present in front of this Shark Tank panel. So that is a panel. This is an event name. Shark Tank is an event name. So once if the investors, they will, there are plenty of investors would be taking part in this event. Once if they are impressed with our product, immediately they are ready to invest whatsoever may be the cost for the manufacturing or for the business promotion. So with this introduction, I want to tell this is a product called a video doorbell. There is a video wherever the house owner may be available, either inside the home or outside the home. Those who are pressing this bell, those who are touching this bell, or those who are near to this camera focus, immediately it will be scanned and it will be sent to the people. Jimmy Simon is the inventor of this product. What is the story behind it is, Jimmy started presenting this product in front of Shark Tank investors. None of them got impressed. Everyone rejected this product. Then he didn't give up. Then immediately he went to Amazon promotion, his own manufacturing unit in the small scale he started. Then he started going and promoting into the Amazon platform. Immediately Amazon, based on the review, based on the product quality and the promotion and the customers satisfaction all together, they started appreciating this product. Immediately they started taking this, owning this product, all the innovation, copyright, everything from Jimmy. Now he is one of the millionaire, as also I can say billionaire. Now this is a person rejected. Now this is a person started sitting into the Shark event panel as a investor. The way he started the journey is a common layman like an investor. Now he is one of the now he's one of the panel member. That is a story I wanted to tell. Anything which we do, this Jam Siphon, now he's investor. He was like a what to say, presenter or innovator. Now he is an investor. That level he reached. So this is the story behind of this product, nothing more. Anything which we attempt and which we do towards what to say, IoT, we can think in terms of product, in terms of project, or in terms of patent, either design patent or utility patent, or in terms of inviting the investors for manufacturing in the large scale. So there is a lot of scope for every one of us to become millionaire and billionaire also with this domain called IoT. So this is the introduction I wanted to start with. Now the evolving Internet of Things ecosystem. Ecosystem in the sense, what are all the component or services or modules or knowledge or intellect required in order to become true, or the product to be successful in manufacturing or in promotion or in services. If you look at what not is available is the question. If we start with this hardware, sensor, chips, service, device, objects, networks, these all related to hardware. So once the hardware is ready, next, software connectivity, platforms. IoT requires a platform to implement and work on carriers, cloud and software apps. So next is rules. We need to understand rules, standards, protocols, consortiums, industry groups and regulations, and government rules. There are several countries, they are against of a lot many what to say, invention related to IoT or application or bringing to the reality is opposed. So that we need to understand. Every country, the regulation towards IoT is differing. It varies. integrating solutions, then how we can integrate with each and every domain. Already towards that activity, someone mentioned it is related to agricultural domain, traffic management, and someone said interconnection of several sensors. So after interconnection, where we want to bring the solution, IT services and management, how we can bring into IT sector this IoT, data analytics and security. This is what the complete focus of this AICTE fund, the complete security concern only, predominantly it will be discussed. However, it is required to move with the foundation. That's the reason we are starting with. So once ecosystem is understood, what are all the required skill set in order to work with IoT in the large scale? Small scale project is different. What is a small scale project is, for example, you can automate light on off. I hope so you can able to see what I am writing. Anyone please acknowledge, moderator. I'm using the Epic Pen. I'm not sure, never used Epic Pen with Google Meet. Normally Zoom, it has its own annotation tool. I'm using Epic Pen. I'm writing light, soft light, smart light, we can say. Am I, are you able to see what I'm writing using pen? Pink color.
Ma'am, excuse me, where ma'am? In which, in the slide or?
Pink color pen I'm using and writing on the slide. Is it visible,
No,
ma'am?
no,
On the pen.
it's not visible, ma'am.
I'm using Epic Pen. I have written smart light. Is it visible? Hello?
Ma'am, it's not visible, ma'am.
I couldn't hear anything.
Ma'am, it's not visible.
Could you see? Hello? Could you see smart light?
Ma'am, no, ma'am. 11 vital skills to become an IoT developer. That's slide only viewing, ma'am.
Thank you, ma'am. It is not recognizing. There is no use of using this Epic Pen. Okay, ma'am. I'll close this Epic Pen. Thank you. Thank you.
Okay. Thank you, ma'am. Thank you.
Yeah, I got it. Now, for example, a smart light. The moment we bring smart light, the moment we implement smart light for one particular house alone, maybe your own house, or you may be doing for your experimental project or academic project, that's fine. So that doesn't require these much skill. The moment you become vendor, smart light automation system, anything you want to deploy across several houses, you should have the tracking mechanism, you should have the troubleshooting mechanism, you should have the maintenance mechanism, you should have the upgradation mechanism. Then you would be attempting towards large scale. Every device, every kit, you will be generating unique identifier through in which you would be working with the product in the large scale manner by the time it is required. Machine learning among 11 vital skill. This is what the first skill people are putting forth in the desk and front desk. Consider the crucial role of sensors, several sensors. Nowadays, people are moving towards green IoT. The meaning, the moment we bring green IoT, either no power consumption. There are certain sensors, especially traffic control management, weather forecasting and flood forecasting, earthquake forecasting, and what else? The related to agricultural automation. Everywhere sensors are required to be deployed densely, larger number group sensor or larger number sensors. By the time we need to think of green IoT, definitely large scale means we need to think of green IoT. What is the meaning green IoT? Is energy consumption should be lower, or it should go for green energy utilization, like solar energy, wind energy, for the self-sustenance or for the electricity. Every component, if you look at the complete IoT infrastructure, 50% the attention goes to hardware, 50% the attention goes to the software. So software need to be executed, processor need to be on, sensors need to be sensing, and all the routers need to function, all the gateways, all the what to say, nearby analytical component, edge component, and the fog computation, cloud computation, cloud light. I will be discussing each and every terminology, nothing to say. So it is surrounded by a lot of hardware, wireless sensor network or Wi-Fi component or modem, anything may be. Ethernet communication or LoRa communication or Bluetooth communication, anything, let it be. It is required the power. Without power, IoT is nothing. So that people are addressing towards green IoT. So this is also a scope. Manufacturing a new kind of sensors, new kind of actuators suitable for the green IoT or cost-wise reduction. Either cost-wise reduction we can keep inventing, or the consumption, electricity consumption-wise also we can keep inventing. So this is another avenue and arena. UI-centric approach. The moment we say IoT, UI is a way a common layman, a consumer, a public, or particular vendor or that consumer or the user will be interacting with your product. So UI should be more powerful, or UI experience should be good enough. So development of UI or what to say, your user interface is another required skill in the domain of IoT. Knowledge of JavaScript and Python is also essential for the web services and web activity. Proven skills in Node.js. This is for back-end technology or full stack technology. What is full stack? Is front end, back end, and complete server handling all together. It is termed as full stack. And DB also. DB, front end, back end inclusive of server handling, web services also. These four together can be termed as full stack. So this is also essential. Security infrastructure and engineering is essential. I'd be addressing upon a few sensor level attack itself. Involved with big data. So this all the data, how need to be stored, how need to be retrieved, how need to be processed, how need to be taken decisions. In-stream analytics and batch processing, offline analytics. There are two different analytics they need to take care. AutoCAD for the prototype designing or the product designing, AutoCAD. Then GPS development, cloud computing, hardware requirement, these all those together a vital skill required. Now you may be perhaps understanding what is interdisciplinary, what is multidisciplinary. The moment the sensor comes into the picture, the moment the hardware comes into the picture, definitely there is a role of electrical or electronics specialist. The moment AutoCAD comes into the picture, definitely mechanical expert need to contribute. All others related to either interdisciplinary agency or computer science. So I doesn't mean that UI is developed only by computer science guy. Nowadays, EC guys also equally good enough in developing UI interface, developing a Python code, developing full stack architecture, something. So it's a kind of interdisciplinary as well as multidisciplinary. Coming to this, what is IoT? Now only the session starts. So for now, I wanted to give some warm up. So now Internet of Things. Anytime, any context, Internet of Things applicable. Anytime it will work. Any data it can process. Any device should be comfortable for processing the data or connecting with the Internet of Things. Any place, any way, any service, any business, any path, any network. That is why I can say IoT is a clumsy and complex also. So it has everything. People are ready to bring. Thing means Internet of Things. Things means what? Living thing, non-living thing. It can be a plant, it can be a dustbin, or it can be a vehicle, or it can be a robot, or it can be a human, or it can be a wristwatch. It can be anything. It can be a camera. So the thing means inclusive of both living being, non-living being. So that is why Internet of Things, anything is possible. Any data, any device, any path means wireless, wired, again optical wired and cable wired, anything, any path, any network, any service. Local area also is possible. Wi-Fi is also possible. Without the internet also we can do with a with low range communication protocols we can do. No need to go for internet services, but the communication is required, essential. Any service, any business, it is suitable for any sector, 24 sector, health sector, civil engineering sector, smart manufacturing sector, any sector is applicable, not necessarily agriculture. Industry automation is also fully dependent on IoT. So this is what I wanted to start with the definition of IoT. Subsequently, when we look at a global standard initiative, IoT definition itself we can address for more than 4 hours. So that many definition, that many contributions people have given towards this way. If you look at any time connection versus any place connection on the move, outdoor, indoor, at the PC, all the 4 combination, any place, based on time and place, based on thing and time and the object, daytime, nighttime, indoor, outdoor, on the move, anything, because Ola and Uber, on the move only it is working. They have IoT integrated chip. Nowadays it is possible to detect, maybe 5 to 8 years ago you would have noticed a lot of mischiefs with women travelers, women passengers with Ola as well as Uber. Then subsequently nowadays they have the kit that need to be installed in the Ola and Uber vehicles. The moment a passenger gets in, either one of their mobile, either driver mobile or passenger mobile need to be switched on till the end of the journey. If both the mobiles are switched off, it will be tracked, it will be indicated, control room will get an alert. If both immediately switch it off, then immediately it will find out the location, geographical location of that vehicle, where it is. Then they can send the nearby vehicle for anything to be monitored, or any suspicious things are happening to be given alert by any other vehicle. Nowadays they have a lot of security mechanisms. So that is the reason I want to touch upon here. On the move also it is possible. Any place and thing and place, between see also possible, human to human, H to H is also possible, M to M, machine to machine is also possible, thing to thing is also possible, thing to thing is also possible, or machine to machine, or there is one more also, they misread it here, machine to machine. Thing to thing, 2 different things can communicate each other. So this is the ultimate definition I can see. In my point of view, I'm telling, I appreciate this International Telecommunication Union definition than any other definition. So coming to here, That is what communication. Then analytics. So based on that, you can analyze. You can initially you can install the smart light and gather the data. Using the data, you can automate or you can build the model. Then intelligent light. You can say that intelligent light. Initially, you can say that IoT, a smart light. You can say. Then you can say intelligent light. So these are all the way. This is the basic or rudimentary level of understanding IoT. Three layers or three component or three major phases. Next, sensing. What and all you can sense, what not. Nowadays, I can say minimum 500 plus sensors available. To my knowledge, I'm telling. I don't know exactly how many sensors are available. Position, presence, proximity. Even in your mobile, the touch sensor is available. So I will conduct one small activity either at the middle of the session or end of the session. How many sensors available in your mobile itself is an amazing phenomenon. So every one of our smart mobile has minimum of 10 to 12 sensors. Then motion sensor, velocity, displacement. This motion sensor, velocity, all for what to say, fluidity, the dam and all the flood detection or dam infrastructure detection, smart monitoring. For those wherever the fluids are available, even for mining, the petrol mining. So the velocity is understood. Temperature sensor, humidity or moisture sensor, acoustic sound vibration sensor, chemical gas sensor for the pH value understanding or chemical molecule understanding. There are several sensors nowadays available for the chemical applications, gas applications, flow control, wall control or flow control sensor or flow detecting sensor. Similarly, force, load, torque, strain, pressure. These all can be gauged or can be monitored. Leakages and levels. These are all nowadays available. Most of the house they are having this smart tank filling, that water tank. They will be installing automatically. This will be switched on, switched off. This all the moment indicator says that the level of water in the tank is lower, then motor will be switched on. Then the level it reached, then motor will be switched off. So electric magnetic field identification sensor, acceleration, tilt. So this all the acceleration tilt sensor is available in our mobile itself. So based on that only, you are keeping the orientation. The moment you keep vertical, the mobile, all the picture or movie which you are watching will be in the vertical. Then the moment you flip in the horizontal, it will be in the horizontal. Machine vision, optical, ambient light. So then camera sensor, so many sensors available just to have a fair idea about sensor. Because most of the time, something need to be sensed from the environment. After sensing only, we can take it forward for the automation. So first level is sensing. So that sensing, we need to understand where we are sensing, what domain, what problem statement or what environment. So this is the base or core we need to understand sensing. Even few of my friends used to have discussion with me for this particular, for example, smart tunneling, that is sanitizer tunneling. Nowadays, the moment the corona effect has come, no, they started installing a lot of tunnels. The moment a person gets in, need to be sprayed. Then the moment it goes away, exits from the tunnel, needs to be stopped. So that spraying also need to be controlled these many seconds. Then how need to be done? Then PIR sensor, range sensor. So like that, the discussion have come. Sensors need to be identified first. Subsequently, communication. What is the way, our complete infrastructure, how much distance it is available, what is the modality of communication, where to where, what are all the things connected, whom to whom we need to communicate. That decides the communication type. See, for example, short range wireless communication, Zigbee is famous. Do the secondary. NFC communication. This is what rocking now. NFC is the latest, I can say, and NFC is rocking what to say, the best or appreciating short range wireless communication. People are telling what is NFC is with a card and a touch card and with a payment device. You can tap these two, then immediately you can start communicating. Two different devices can communicate NFC. If these two, any two mobiles are tapped together, the recent Samsung mobiles are having these all NFC. So NFC enabled. In my mobile, I don't have. I have only Bluetooth and Wi-Fi, these are. So these are all the way we need to choose a communication. Depending upon the application only we can choose. Whether we move to cellular communication, this is suitable for long range communication, larger infrastructure, many node and sparse or dense infrastructure, definitely we need to go for which category 3G, 4G, 5G, that we need to decide. And low pan, LP1, LoRa, SIGFIX. Yeah, LoRa is useful for within the near field faster communication. So for example, agricultural field. So within your land, you may be having 5 acres, 10 acres. Within that range, if you want to go for fastest communication, then you need to choose LoRa. So I have written few points here when to use. The moment you step into your IoT project, I have few thumb rule. Very first thing is purpose and requirements. We need to list out our purpose and requirements. Process model specification, all the use cases, where and all it is applicable, what are all the uses. Then domain model specification, physical entity, virtual entity, devices, resources, services in the IoT system, we all need to list out clearly. Information model specification, the structure, how the information is communicated across different entities, what are all the relationships, how many attributes are associated, what is the type of data, nature of data, service specifications, what is the mapping services, mapping device to communication mapping, communication to application layer mapping or user mapping. So all the mapping process, IoT level specification, the level specification in the sense I will touch upon that levels. So whether you are working in cluster of node or single node or multiple node, something edge computation, fog computation, cloud cloudlet computation, or all mixed computation, that is called level in simple term I can say. Similarly, functional view specification, operational view specification, what are all the services, device and component integration, deployment, application development, all together you may need to list out first. Depending upon that only the particular technology or protocol or the hardware can be chosen. There is no thumb rule for IoT to start with. For the academic project, I can start with, you can either start with Arduino or you can start with Raspberry Pi. So what is those two difference? Let us see shortly. In analytics, so the moment data generated, acquisition, gathering of the data, marshalling, then conversion of the data, completely the format need to be changed, the representation need to be changed, that is called marshalling, analysis and action. So once the data is accumulated, then how to take about, see Ola and Uber, imagine every city control will be playing with minimum 1 lakh vehicle, or I can say minimum 10,000 cars associated with their business. So imagine 10,000 cars, they need to acquire the data first, then marshal the data, analyze the data, action. On process, immediately they need to take decision, at time they need to take decision bit later. So all together they need to work on this. Next, now only we are coming to little more deeper understanding of IoT architecture. See, sensing layer or hardware. What are all the hardware we want to work with? That we need to first complete. Hardware connectivity, power distribution, how many resistors we need to use, where to control the power, how many pull-up resistors we need to use, how many pull-down resistors we need to use, is there a requirement of capacitor. Every device attached with your infrastructure will have different voltage, the complete power management, voltage distribution, so that voltage calculation, that all those things need to be taken care in the sensing layer or hardware layer. Next, network layer, how we are connecting together all the things. Things means what? It can be living being or non-living being. How need to be connected? Only with the support of network layer. So how these two things can be connected or different things can be connected, that we need to work it out. Similarly, how we need to process, whether you are doing simple automation, also data need to be processed. That how the data need to be processed, data need to be gathered, data need to be stored, and data need to be analyzed. All those things together, action need to be given. Similar, gateways main role, main component in the network layer, local gateway or it is international gateway, anything you can consider. Then local gateways related to your own network for device identification or device communication protocol, something like that. Then when the moment we go for proxy server, international gateway, that is for WWW standard. The WWW standard, the messages need to be communicated, need to be authenticated. So for that, gateway is useful. Processing unit. So next processing unit, GPU, TPU, CPU, any type of processor. There are 3 type of processor recent days exist. CPU, central processing unit, graphics processing unit, GPU and TPU. Then application layer. So what is the way we want to apply the infrastructure? Medical application, it is different, and the field services, all the transport services, it is different, and all the end user, public user services are different. So it is depending upon the application we need to work on. So first we need to synthesize these 4 major layer in our project. So now little more detailed I'm bringing to the scenario of IoT solution architecture, sensors and actuators. First, we need to understand what are all sensors and actuators involved in our project. Then that type, wired and wireless, that we need to synthesize first. What is actuator? Finally, the end product need to be automated or controlled is actuator. There is no single definition. Nowadays, polymer actuators are coming into the picture. That is one of the green IoT control. Similarly, people are designing sensors based on green IoT concept. Nowadays, both the sensors and actuators, both are based on green IoT. Similarly, cars also, temperature sensor alone, you can find more than 10 types to 20 types temperature sensor alone, I'm telling. So depending upon the material which they use, durability, reliability, and all those things, and the power consumption, these all together, it is the price is fixed. Sensor is going to sense something. This is the initiating layer of the architecture. What is actuator? Finally, what is action we need to take upon the complete communication is actuator. For example, motor. Our home, we have most of our, at least our no person would be installed with IoT based, now what to say, motor control. So your motor valve, electrical signal need to be converted into mechanical torque. So that torque will take action on the actuator. It will control when to switch on your valve or the motor, when to switch off your motor. So completely motor need to be activated. In this scenario, motor is an actuator. Smart light automation. The moment you look at smart light automation, sensing is what? Intensity of light or anything, object. Either based on street lights are based on intensity of the light illumination, whereas house, it needs to work based on the human, or at least it should have a mobile control. You can be at a different room, or you can be away from your home. You should be in the position to control the switch. So based on the sensing medium, actuator need to be. Without sensor also actuator can work, please understand. But without actuator, no sensors are useful. There is no need of sensors. Directly you can control through UI also. It is possible, but actuator is important. Actuator comes to picture for take decision, automatic decision mainly. We are going for IoT. Then actuator is must. Next, internet gateway or local gateway. Local gateway is for your device control or the main purpose of gateway is for authentication and communication. So in and out of data, flow control of data or messages, information are controlled by gateway. Data acquisition, data aggregation, these are all together the second stage. Next, edge IT, IoT or edge analytics or fog computing. There are 2 different words. I have different slide for those 2. However, I will give a small introduction about edge computation or edge analytics or edge processing, edge computation, computation. These are all the 2 computations are focused. Anyone wanted to do research or submit a paper, the hit of the paper, success rate of the paper would be much more better for edge computation or edge analytics, fog computation or fog analytics. These 2. What is these 2? Let me come to the picture. Edge computation is on the node, on the device itself, either node or the device. There are a recent day coming with processing ability. Otherwise, you need to deploy a separate circuit. The moment sensor data is brought to that device, immediately nearby that sensor, in the moment or nearby that actuator, wherever, it needs to do analytics. Immediately decision need to be taken. For example, camera, surveillance camera, anything goes riot, public nuisance or public fight is happening, immediately that surveillance camera need to detect that and need to intimate, give an alert. So there is no more delay in it. So every frame of the video is analyzed periodically, at least once in a minute so it needs to give a alert to the nearby police station or nearby concerned. By the time if delay happens, what would happen? Something go wrong. So that analytics need to be done on the device itself in order to take decision. So that is edge analytics, edge computation. What is fog computation? You may have single node or multiple node. Node means what? Hardware. Elements I can say, hardware, circuits I can say, number of component I can say. So you can establish a local area network. For example, if you are going agriculture automation, it is not necessary to connect it to cloud and all. You can do a local area network establishment within your range, within your 5 acres, 10 acres, you can start doing automation. So within your range, you need to do analytics. It may have several sparse dense or densely deployed sensors. So much unit you may have, irrigation unit you may have, then pest reduction unit you may have, or soil dryness reduction, pH value reduction. Imagine you have different perspectives. Then every component will have separate unit. All unit together to be processed in the local area network. That is called fog computation. For one particular node, if the processing, if the analytics is carried out, that is called edge computation. Multiple nodes in the local area network, if you want to do a computation, that is called fog computation. But however, both are done nearby the device itself, architecture itself. The moment you deploy or acquire or gather the data into the cloud, after bringing all the data into the cloud for analytics, that is called cloud computation. So these two vary from perspectives. So the moment you go for cloud computation, what is the problem is latency delay. Your data need to go to the cloud, there in which the analysis to happen, then the actuator, controlling the actuator or decision making would become bit delayed, latency delay. That is the reason we cannot rely on Wi-Fi all the time. Although internet is good, by our tower need to work. Our network, you may belong to any one of the telecommunication service, Airtel or whatever, that BSNL, whatever. So we don't know how the quality on that day, the traffic on that day. So we cannot rely on that. So certain primary analytics need to be done at the edge level or done at the fog level. That is one scenario. What is the need of going for edge analytics and fog computation is another scenario. Cloud is costly affair. You can't dump all the information whichever comes from the sensors or whichever comes from the input on the cloud. You need to take decision. What are all the data essentially useful? Data transformation or data selection or data filtering or feature extraction. Finally, essential data need to be deposited into the cloud. So that people are mostly concentrating towards recent days on the edge computation and the fog computation. How it can become successful in order to reduce the cost of the cloud, how the edge computation can be improved, how the fog computation can be improved is a point of discussion going on. If you look at, there are 4 stages this slide demonstrate. Every stage, the security is required. Sensor level security is required, gateway level security or firewalls or all the proxies required. Then edge level, computation level also required, cloud level is also required. Security is required in every layer or every level. So there are devices people are manufacturing, a ready-made kit, ready-made platforms people are manufacturing with more security when it comes to stage 1. Similarly, stage 2, we need to sit and study which protocol, which mode of communication have different way of security mechanism, and what are all the protocol suits with what are all the type of what do you say, firewalls or kind of antivirus, so many things. So this all need to understand, and we need to deploy all along into this level. Every layer we need to think security. So that is what the focus of this STTP alone. Let me stick to the overview of that rather than the security. So this is what the holistic picture. Again, coming to here, one more holistic picture I want to bring. Gateway, say sensors, actuators, and all the smart devices connected to the gateway. The moment we call it as a device, any hardware device comes, every device must have unique identification code. Without that unique identification code, any signal comes from the device, gateway will not process, will not understand, will not accept. So that is where gateway is essential. You can say at your end, local gateway can be your hub, your router, and what is that internet gateway? Completely that is centralized. That allows any communication to happen based on WWW standards, World Wide Web standards, or HTTP protocol standards. So it works on either HTTPS or HTTP protocol or WWW consortium standard. That is internet gateway. So when you want to bring your internet IoT infrastructure, internet, what to say, of things, anything you do, if you want to bring into internet, then you need to be in the need of internet gateway. Otherwise, local gateway is sufficient. So one router is sufficient to establish your local area network. The moment any device we bring into communication or attachment to the internet or local area network, definitely gateway is required. The moment you wanted to connect two different devices together itself, you need a gateway. Then cloud gateway, this is for finally to store your gateway, web application or mobile application. You need to decide for the user point of view or both. User business logic, data analytics. See, sensor data, from the sensor data it goes to data lake. Raw data go to data lake. What is data lake? I will shortly address. So this is a buzzword. Recent day, the moment you say big data, people moved on to the data lake. What is the data lake? Shortly we'll discuss. Sensor data. From the sensor data, big data warehouse, and control applications. Finally, it should control. So from the control application, there are machine learning model. If you wish, you can go. Not necessarily to have the whatever it is projected on this picture. This is for a bigger, a massive scale enterprise applications. For example, Ola, Uber. These are enterprise applications, all the cargo services, flight services. Every flight is attached with thousands and thousands of sensors. The moment one flight is operated from one city to another city, 1 hour, the voluminous of data which you are imagining to the cloud application, it will be tremendous. So those kind of application only, whatever it is projected on this, it is essential. So streaming data processor, sometime the moment the data arrives, streaming time itself need to be processed. Cloud gateway, the moment you want to deploy it into net through cloud, then you need to use this cloud gateway. Then control applications, from the control application, the flow comes to user business logic. That is what I said initially. You need to identify the problem statement, domain, and all the internet communications and all the services which you want to provide. That is, we need to have a complete template or flow chart or mind map. Only then IoT you can make it to become successful. Otherwise, it is very tough. You can't do trial and error. We need to have concrete idea what application we want to do. Relevant to that, we need to go in deeper. The moment I say Zigbee communication protocol, what is Zigbee? I no need to, I may know only the definition right now, but the moment I prefer Zigbee is required for my particular application, I need to go in and out how I can do coding to bring Zigbee, and what are all the pros and cons of Zigbee, case studies, what are all the existing use case studies. All I need to do, brainstorm, I need to understand, I need to take decision. So the cost is a matter. Anything which we know we can't deploy, we need to think for scalability, adaptability, and what to say, configuration. The anything we want to upgrade, you suppose you may be doing 4G, later on you need to upgrade with 5G, then configuration, that all those things it needs to withstand. So that we need to understand what is useful, what is our future business scenario, what is our present business scenario. All together we need to connect. Depending upon that, we need to go for architecture development. Now second question is, IoT and CPS are same, cyber physical system are same? Yes, both are same. The moment you say cyber physical system, machine to machine, all the non-living things, only machines can get connected. That is the only difference. All other things are same. IoT means human machine, machine to machine, all those combinations together. When it becomes cyber physical system, I can say M to M, I can say. That's it. So coming to here, sensors, let us touch upon a little bit of sensor. Actually, we have only 45 minutes or exactly 1 hour more. I may not conduct the activity. I used to have a small activity, giving the scenario, asking the audiences to list out what are all the sensors we can think for this scenario. That kind of activity I used to do. But due to the time constraint, let me move on to this. So for example, if you are going to do anything DST sponsored, CERB sponsored, MHRD sponsored, AICTE sponsored projects, anything sponsored projects only I mean to say, or if you are well off, you need to rely on Libilium. You search the internet, Libilium is a product vendor. So they have their own website, Libilium product. So you can purchase this. This is reliable, industrial graded. So what are all the product they are selling in the Libilium platform? They will be, they all are graded by the industrial benchmark and standard. That is the worth or highlight of Libilium. When you go for Alibaba, Alibaba has plenty. That fellow sells what not. So I cannot assure for your quality. You may get a cheaper sensor also through Alibaba, or you may not get a cheaper sensor. That whatever may be, I cannot assure for the reliability of that sensor. Similarly, Amazon also, if you purchase, I cannot assure. So if you purchase through IEEE standards, then reliability is good, much better. But this is one of the commercial website, I mean to say, other than technological consortium, if you want to buy, or you can buy Texas Instrument, that is your choice. But commercial aspect, I mean to say, Libilium. This comes with industrial graded. Then photodiode, photo transistor for ambient light sensing, smart light. If you want to do, you need to identify all the sensors suitable for that application. Then you need to understand the pros and cons of each and every sensor. So that is what I mean to say. You need to go for exhaustive study depending upon your domain application. I myself cannot sit and study all the sensors. I cannot become expert on all the sensors unless otherwise I work on sensor. So similarly, movement, PIR sensor, passive infrared sensor. So for example, social distancing alert, there are several applications people have developed during this pandemic. So this it will give the alert. So the person comes more than 1 meter closer to you, then PIR sensor. Anything, this one PIR sensor, vehicle parking is required. PIR sensor, where it is required, just imagine. Anything, what to say, prohibited area, if you enter, it will give you alert. So there are several applications for the PIR sensor. You please go through it. Then pressure sensor, all the water related, either wastewater treatment or water metering. future how current meters are available. Similarly, water metering going to be deployed already. Several countries, those who have water scarcity, they have that water metering technology. Barometer, flow and level sensors, pH value, TDS and pH sensor, these are all the sensors. Differential pressure transducers, flow sensors, magnetic sensor. Whenever you go into dams, flow, water inflow, water outlet outflow, or tank, everywhere you need to have differential pressure transducers. So next, coming to this all, you may be amazed what this all. This is called Arduino Shield. Arduino has basic kit. Arduino is a microcontroller, whereas this Raspberry Pi is a processor. Similarly, instrument CC3200 3200, one kit is available, that is also a processor. The moment we say processor, this processor can be used for the real-time application, whereas Arduino, maximum real-time application, yeah, small applications you can think of, but Arduino is best suitable for academic with a cheaper cost. Arduino you need even buy. Tomorrow I would be addressing in another session, one more session I am invited. Completely I'll be addressing about Arduino academic projects, hands-on with the coding. So Arduino coding we will be discussing. By the time you will come to know. Suppose if you want to bring Arduino for something like a real-time application with application, then you need to bring a Wi-Fi shield. There are two layers you can see. It's like a deck. The top layer is a shield for Wi-Fi. A bottom layer is a Arduino microcontroller kit. Similarly, this LilyPad Arduino, you look at this circle like this is a very thin and tiny Arduino. Arduino itself has minimum 5 to 7 variant, different flavors of Arduino available. This LilyPad Arduino, even we can stitch in our cloth itself. This Arduino kit we can carry in our cloth, in our dress itself we can stitch. Next, this is called particle IO. The last one I am showing, particle IO. This is for handy applications. You can understand. See how much smaller it is when it compared to all other devices. This is Intel, their own IoT processor kit. See, this Intel is useful. 1 minute. This Intel is useful for especially industry application. This is Intel created for industrial application. The top one, black one, Node MCU. This is for green IoT. This is IoT. This IoT platform for green IoT. The moment we start discussing about sensor, where we need to connect is the discussion. For that, you require some platform. Raspberry Pi, Arduino, or Intel. Cisco also they have their own. IBM also they have their own. Every vendor they have their own controller. If you see today, several plenty. BeagleBone, I'll be discussing a little bit later about those all. So these are all this is particle IO. We need to find out the kit for our establishment. This particle.io is useful for handy application, anything which you want to carry while traveling, or it should look elegant at your home, then you need to go for this particle IO. This is for industrial automation. This is a platform you need to buy and you need to develop application, not the Arduino or Raspberry Pi. Industry perspectives. This is green IoT, completely low power consumption microcontroller or processor. So this is what a Node MCU. So these are all those fair idea we should have. Even I don't know everything, whatever I know, but this awareness is required. Sensor awareness and the platform awareness is required. Only then you can move forward. So first we need to decide the domain and the use case. What actions we need to take. Then similarly, next to the sensor, you need to work on actuator as well. Actuator I'm not bringing because no time to sit and prepare this slide, although I know few actuators. So let us move on to the next. Now the hardware layer I discussed, or I had given a glimpse. I am not addressing a detail, some fair idea, justice I am doing for this session. So similarly, actuators, IoT technologies and protocols. So you have several protocols: Bluetooth, Zigbee, Z-Wave, cellular, Wi-Fi, NFC. Cellular is 1G, 2G, 3G, 4G. You are talking about that LoRaWAN. So which one you want to go for? That decided by your use case. There is no general idea. No, I cannot tell this is what the better. what is application you want to develop. Similarly, NFC is recent day more people are working on NFC, near field communication. This near field communication is working based on RFID, infrared identification. So what are all the way you can use? You can see, look at this picture and you can able to understand and the cashless payment and what else, identification, a human identification through your tag and physical access to different machines you can communicate each other. So this is what application you can think of using NFC. IoT protocol, the famous protocols I'm telling for IoT protocols. This is in general based on the ranges. Again, I have several slides to give you clarity when to use what. Shortly, we'll be discussing. So most of widely used protocols only I have brought in. COAP. The COAP is called Constrained Application Protocol. This is useful for M2M communication, machine to machine communication. Two different machines you want to automate or communicate here, then you need for M2M. Similarly, IoT system based on HTTP protocol only you can use. The moment you bring HTTP only, COAP can be used. The most widely popular, big appreciated protocol is MQTT protocol. So that MQTT protocol I'm discussing in the subsequent slide in detailed manner. Message queue telemetry transport protocol. This is much more important. This has security. Next is advanced message queue protocol, AMQP protocol. This uses publisher subscriber model. It uses the data structure called queues. So through queues, it will be all the publisher will deposit in the queue. The messages are deposited in the queue. Subscriber will start accessing the queue for fetching. Whereas in the MQTT broker, there is one more broker, mosquito broker. You know, mosquito will bite us, no? Mosquito broker. So this mosquito broker is variant of the latest version variant of MQTT broker. MQTT protocol is also working based on publisher subscriber model. Only the difference is MQTT broker is sitting and giving authentication between the publisher and the subscriber. None of the publisher and subscriber cannot communicate each other. Only through MQTT broker only the communication is possible. That is the only difference between MQTT and AMQP. Although it looks like same, MQTT is preferred a lot by the audiences or the developers. Data distribution service. So this is useful for scalable, massive level communication like Ola, Uber, we are telling, or flight services, real time, reliable, excessive overall performance is required. You are expecting precise performance. Flight services, something goes wrong, what will happen? All the VIP will be traveling. So it needs to be ship. All the movement, the cargo movement need to be detected. Interoperable statistics are required. By that time only you need to use DDS. Just because of the appreciation, we cannot use small level of development. So this is expensive. So we need to decide what application we want to do, how long we need to run business, what is the future expansion. All those things we need to connect in our mind, only then we can decide the IoT protocol. Now we are going for MQTT protocol, a little bit discussion. Look at here, humidity sensor deposits the data to MQTT broker, then on-premise analytics, cloud analytics, both are possible. But through broker only you can take data. So without broker, directly you can't access and you can't communicate. So this MQTT broker is responsible for authentication. That is a highlight or advantage. Through that you can improve the security. So now it is essential when the response time, throughput, lower battery and bandwidth usage, if you are preferring, then you need to use MQTT protocol. Green IoT, it supports only MQTT. MQTT is a lightweight protocol that runs on top of the TCP/ICP protocol. There are two protocols, UDP, TCP/ITP, for the network communication. So among those two protocols, MQTT is suitable with TCP/IP protocol. So this uses public subscriber model, and also it is suitable for WebSocket. WebSocket is essential for UI interface. So application layer, WebSocket only will helpful. So it is user friendly also. green IoT friendly also, lightweight also, among two communication network layer protocol, TCP/IP protocol and UDP protocol. MQTT is suitable for TCP/IP protocol. You decide which you want. So the fair idea, sir, we just look at intelligent lighting system, daylight, sounds, people's movement are observed. So either you can develop a intelligent lighting based on sound. You can say, hey, come on, light on. If you say, if you create sound, that sound wave vibration is detected and light be switched on. Or not necessarily to give, hey, come on, light switch on. You can just create any noise, like how I'm sitting and speaking in my room, no, in my cabin. So immediately the moment it understands, it senses somebody is there actively involved, then it can switch on. Or else movement, my movement it can detect, or my physical detection, the appearance of the human need to detect, or light. So different application requires different way of thinking perspective. Similarly, we no need to sense anything. We no need to buy a sensor or smart home automation. Only through our mobile, we can lie down on the bed. We may miss out to switch off the light in the kitchen. So sitting here, we can switch off. What is the number of the light we have given? We need to open the UI application. We need to switch off that light using on off button. So no need of sensor at all for this application. We need to decide. Then instead of sensor, in that case, UI control only will come here. Raw data goes to data lake, extracted information, data lake, it starts extracting the information and it goes to the warehouse. Then from the warehouse, the data can be supplied to the analytics, or it can be supplied to the control application. There are certain information directly should go to the control. There are certain information should be given for the analytics for later decision. After control application, acknowledgement also deposited to the warehouse. Suppose I am switching on the motor. So it needs to give me this signal, whether it is switched off or failed to switch it off. So it needs to give. Then from the model, it can take decision to adjust also. From the model also you can control. Partly you can control through the data also. Then from where actuators, smart lamp comes to the picture. So the relevant command to the actuator need to be given by the control application in order to switch on. Actuator is output. Actuator only will make the thing to happen. Sensor will start the process. In between, these are all required. Layers, servers, and all those things required. Now, just I will discuss sensor-based threat. Extensive literature available. There are several universities working on IoT security itself from Israel. Israel is one of the country. There are several university professors working only on this IoT security itself. So keystroke inference, light, motion, audio, video, light, magnetic sensor, these all can be hacked. That is what I mean to say. So the moment you are using mobile, know how you are touching, how you are pressing, which location you are pressing, all those things can be tracked by the hackers. So what you are typing, for example, if you are giving a PIN code for your mobile transaction, so how you are giving your username, how you are giving your password entry, all together through our touch, because it has a keypad, no, A, Z, the same, I'm looking at my laptop, Q, W, E, R, T, Y, the same order is arranged in the mobile also. So it has that positional arrangement, where I am touching, that vibration it will detect through light, through motion, through touch. So through that, it is possible to hack our mobile also. Task interference. Similarly, task, you will be giving command, you just go back, what are the tasks available? You are controlling the actuator, you are sensing. So here task comes. Sensor senses the task, actuator actualizes the task. So the task can be attacked during the communication. Location inference. So finally, based on the location also, it can go for attacking. Next, eavesdropping. Eavesdropping is one of the method. Many IoT devices uses audio sensors for making calls, recording audio messages, receiving voice commands. So recent day, lot of serials also they are showing. It is happening also. Even a lot of few celebrities during lockdown, they have got a call exactly from their own friend number. So, but someone else, not their friend at all. So through that, it is possible to detect, deploy audio sensors so that they can make this all the kind of activity. Transmitting malicious sensor commands, they can give malicious sensor commands also. Not at all our own sensor command. It will give, for example, look at it here, actuator. They can hack, they can switch on all the time. Not at all your own process. You would have done these all the deployment, but that command would have given by the hacker. So it will control, it will be the actuator part alone controlled by those fellows. So most of the IoT is working in autonomous vehicle, all the autonomous two-wheeler, four-wheeler. Recently, BMW released a two-wheeler also, autonomous two-wheeler vehicle also released. A lot of things happening through IoT. They need to be safeguarded. Then especially patient. So health sector require more security. Every sector, not necessarily. Next, false sensor data injection. So they can send similarly like your sensor which you have deployed, false data they can inject. Denial of service, completely they can hack, they can arrest your application. Denial of service also they can happen. These are all the level of attacks or threats associated with IoT infrastructure with the minimum level. I am not even touching upon communication level, application level and all, with the minimum level of attack and threats available. Next, LoRa. This is for long range, low power wide area network, LP-WAN. Whenever you are using long range, low power wide area network, then you need to go for this LoRa protocol. So this is what one I want to bring, nothing more. So IoT device layer, any device, see, it can be sensor, it can be IoT platform or kit, anything. After that, fog computation. I said fog computation now. This is kind of several devices together in this cloud, so that fog computation comes. Next, application layer. What you want to control? Whether you want to control your monitor or your anything else. So that is application layer. Or you can generate report. You can see the data. You can analyze. You can control. You can control the actuator. You can give the command for any services. All together, it becomes application layer. Now, how the data moves? Look at data collection, data transmission, data aggregation, data distribution, data consumption. So these are all the flow of, or this is the way the flow of data happens. IoT characteristics, ambient intelligence. It should be able to, this is for data or event driven. So either way you can work on data driven application or event driven application. Next, ambient intelligence. It should be able to take decision. It should be able to sense what is the input comes. Flexible structure. You may deploy sensors today, maybe smaller in size. Later it may be larger in size. Later it may become dense in nature, so sparse in nature. It should be able to withstand. Semantics sharing, context understanding is important. See, in that lighthouse, there are three contexts are given. This light, look at, there are three contexts based on the light, based on the sound, based on the movement, kinesthetic, acoustic, visual. All the three types of inputs are given. So on which input or all the input or combinations we need to sense. So that is what the word. This is what semantic sharing, complex access technology. The same device may need to see, for example, your mobile is working on Wi-Fi, your mobile is working on Bluetooth, your mobile is recently working on NFC, that is Samsung Galaxy is working on NFC also. So it should able to communicate with different kind of, what to say, uh, interoperable devices. So this is what characteristics of. So now let us look at what is edge computing and cloud computing. Look at here, there is a several source of data comes and flows here. Data and analysis here happens at this level. this level itself, analytics, data analytics will happen. So that is edge computing. Cloud computing, it will be deposited via network. See, look at, there is no network at all. Within that, your infrastructure limit itself, computation is happening. Through network, the data is deposited to the cloud. From the cloud only, the computation will happen. That is termed as cloud computing. Next, further micro level discussion, what is edge computing? See, these are all the devices or sensor. The data may go and come out, flow. These devices has sensor or without sensor, the device is also. Look at here, real-time data processing, basic analytics is happening. Edge level, edge means that node level, infrastructure level, without even touching into the internet level is called edge computation. Please understand. Data catching, buffering, optimization, machine to machine. For after these all analytics, you need to go for filtering, decision making, controlling, and you need to decide what amount of data, what quality of data you need to send into the either data center or cloud. Big data only we can call it as data center or cloud. So that cost will be reduced. Cloud is most expensive medium, so that we need to reduce the expenditure. For that, we need to take decision what information. For example, surveillance camera, video analytics. Those days, whatever the data comes, you need to stream it to server. You need to deploy it to the cloud. Then finally, after a month, after a week, after 2 months, if you don't have any fishy things or nothing is required, then you can sit and delete, or automatic delete can be happen for video footages. Recent date is not recovered. What kind of deduction for if the camera is installed in the ATM, all the malicious activity only it will be deducted, all those activity only it will deposit. Anything goes normal, it will not be deposited the cloud, only at the local end. That local end will be maintained for a couple of months or couple of weeks, then that will be deleted, auto deleted. Whereas the cloud data will not be deleted, or few frames per movement. I may enter, couple of frames will be stored in the cloud, or another guy will enter into the ATM, then that ATM bank, that a few frame, a smallest footage of every identity. So some logic is applied. So the filtration of data, avoidance of larger information is reduced. So that is also one of the edge computing. Not necessarily to the decision making or controlling the actuators or controlling commands establishment. Sometimes data analytics for filtration also may happen at the edge level. It's very popular domain recently it's going on, edge computing. Look at the scenarios. So cloud lit, a small tiny cloud attached near to your local area network or near to your computing services is called cloud lit. Cloud lit means droplet, we will say, no, it's a tiny cloud, that's all. So look at case one. What is doing? Edge computing, going for fog computing or pervasive computing by the cloudlet. The moment we use cloudlet, gateway is essential, a miniature cloud. Then after this cloudlet performance, it goes to the cloud. Next, this is edge computing. Directly it goes to the cloud. Next, case 4, edge and fog computing both are available. Node level computation, local area LAN level computation. After the computation, the data is deposited to the cloud. IoT collecting data from directly, data collecting, you are putting it to the cloud. Look at that 4th scenario. First one does some computation and puts into the cloudlet. From the cloudlet it goes. Second one, larger computation, edge computation, fog computation, both are happening. After that, it is sent into the cloud. Look at it here. First one, it does some computation and it goes to, from the gateway, it does some computation, goes to the cloud. This one directly, there is a device, directly communicates to the cloud. So what the kind of service you want, you can take. What is cloudlet? A sensor node, otherwise remote. There are 3 types of famous modes are available. You can explore later. Is a node is sensor network capable of performing some processing, gathering sensory information. communicating with other connector nodes in the network. That is the role of cloudlet. A mode is a node, but a node is not always a mode. That you should understand. Since when the cloudlet is useful, sensors are deployed heavily, group-wise sensor, processor may be temperature or pressure extraction, long range communication, short range communication. Based on these all only you need to take decision whether cloudlet is required or not. Cloudlet is an infrastructure established between gateway and to the cloud, in between via media, gateway and the original cloud, in between the cloudlet, a small or tiny cloud. Cloudlet is a mobility enhanced small scale cloud data center. That's all. This is mobility enhanced small scale data cloud center. That's all, data center. So that this will have low latency because it is a nearby infrastructure. Quickly it will work on and it will transfer data. Next, features and scope of the IoT system. So the most we have touched upon: unique identity, ubiquity, self-configuration, self-adaptation, interoperable communication, sensing and actuation, programmability. All these features together the scope of an IoT system. Look at here, these are all the layer: connectivity layer, that is a physical layer, silicon layer, operating system layer, middleware layer, information, application layer. These are all cross layer concern. Hierarchy level, this side A, B, C. So this you can have product edge, deep edge, gateway edge, edge computation. I was telling now where the edge is located: network edge, private edge, co-location edge, public group, public cloud edge. Next, what are all other supporting our interdisciplinary activity? Management, complete infrastructure management, device management, user management. There are three different management: user management, infrastructure management, and device management. Virtualization, maybe only one operating system will be available. Virtualization, hope so you may be knowing. Containerization, virtualization. So it will create a virtual operating system for each and every user. Acceleration, real-time allocation, security. So these are all interconnected. A holistic picture now I am bringing in. The detailed picture to the holistic picture. Hierarchy level, cross-layer level, edge level, and all other supporting services required. These are supporting services: management, virtualization, acceleration, real-time, security. These are supporting services all together in one picture. Look at here. Now little more detailed picture compared to this picture. Now little more. What are all? Hardware platform infrastructure. What we want to go for: mechanical, power, cooling, or classic. What kind of thing we want to go for? Protocol abstraction layer and network layer. Accelerators we may need to use. Computation, storage, node security, hardware security, HW security, open fog node management. The several nodes may be playing a role together. Node management, hardware virtualization, software virtualization, both are available. Then node management, software backplane, application support, application services. So these all together only it plays. And security, then manageability, data analytics, and minute. There are several notifications. Yeah, finally, application layer. Now these are all the protocol. Look at this: hardware, protocol, decisions, or control, or reporting. Anything can happen. This is another way of looking at the standards and the protocol. Little bit detailed in one picture. So all the IEEE standards related to hardware related to IEEE standard, or Libelium product you can look at, RFID NFC, RFID VPC. So what you want to do, VPN or NFC, all those together we need to take decision. This is called physical layer, data link layer. So it should communicate with data, either Wi-Fi or Zigbee enabled or Bluetooth enabled or RFID enabled, that all together it should have data link layer, network layer. So IPv4, Internet Protocol version 4, version 5, version 6, there are 3 available. You need to sit and study which version is suitable for networking purpose, or low pan or RPL, which one we want to use. Transport layer widely used or TCP, next used as UDP. These two are popular. Some subsequently TLC, DDLC. Application layer, here another layer, MQTT, XMPP. This is for document XML structure data communication, or JSON data. Anything you can represent through this communication. Next is cloud services, device management, business solution, data aggregation, all together can be done with the cloud services. Security, privacy protocol, security protocol we need to think for every level. Coming to the last level, intelligent transport, smart city, home automation, healthcare, IoT application, anything you can think of. Again, synthesis, but hope so you would be thorough enough by this time. Sensing layer or a physical layer, network domain or communication layer, application layer. This is detailed with micro level information. Smart city. What are the way? Smart city is famous and popular projects everywhere going on. Shortly, India also will be giving DST fund for smart city also. Even nowadays, it is available like this. So if you look at intelligent traffic management, electronic vehicle charging infrastructure, and what else? Network routing, traffic light, bus stop control, and LED street light, car charger, information panels, all the information it should give, the layout of that location, all those things. Cabinet and water, flood or rainfall detection, all those information, temperature detection, it should give complete automated information. Pollution control or alert for certain limit of pollution moves in. Video surveillance, all together is termed as um, smart city. Even you can think of anything goes wrong, immediately ambulance should reach quickly, or the physicians should reach quickly. You should give information nearby hospitals. All together only smart city. You can think many level. Pollution control, greenhouse monitoring, anything you bring to the welfare of the city, it is termed as smart city. That's it. Water metering, and all automated, tank filling and interconnection, overflow detection, tank overflow detection, water control, everything you can automate together. And wastewater management, all together you can say as smart city. And all the waste detection using sensor, whenever it is overflow happens, no, that dustbin, street dustbin, nowadays periodically whenever those guys are free, they those time only will become will be what to say, collected all the garbages. So the moment the garbage bin is overflow, it will be deducted to the corporation. All together it is said to be smart city. So you can, recent day, smart transportation, most of the developed country, one of the indication is people satisfaction level, and in 24 hours power supply with a cheaper cost is one of the requirement of developed country. So many parameters are available for declaring the country is a developed country. So among that, these all, what it does is, the moment train comes, it will start detecting the faces of all the passengers. How many seats are available, it will display these many seats only available, you are these many, and wait for this, the other train is nearby. So like India, we will stand on somebody also, that is the way we will travel. We will sit on somebody's shoulder also, we will travel. So that is the scenario in India. There are countries, they don't even allow to stand, the even passenger, they don't feel like to stand after paying the ticket. So those are all the countries, they go for deducting quickly, rapid fast deduction. These all fall into smart city category. So any perspective you can think. I used to go for half an hour activity with the smart city alone, but there is no time today. We need to move forward. IoT enabled devices, what are all the devices you can enable, what not is the question. Mobile you can enable, vehicles you can enable, Next, water metering. So you need to identify water resources, and you need to identify the capacity of tank record for the complete history, complete automation, pinpoint detail. If you ask now any municipality officer how many gallon of water it is consumed per week in this zone, nobody has no clue. So what is a water inlet flow? What is the tank capacity, dam capacity? What is the tank capacity? How many times you are filling the tank? So no clue, no calculation. Simply we are fluke like we are working. So somehow they will be bringing all intelligent metering system, water flow and water inlet, outlet, and consumption, and what is natural resources available. All those things together. Wastewater management, pH level. So certain beyond certain pH level, even the sewage river like Coom is floating in the city, that is also harmful. They need to control some amount of some level of pH through chemical processing or through cleaning or through filtering, something they need to do. So completely wastewater management, it is zero, I can say, in India. Recently DST have come up with a lot of funding opportunity for only wastewater management. I didn't apply because I am not having any clue on it. So smart water management, AI based water cleaning, water recycling, or industry recycling, plastic recycling, bios recycling, and they have given medical product recycling, and all the hospital wastage recycling, and the electronic goods and services recycling. So many recycling techniques they have come up with the project funding proposal. So that also fall into wastewater management and control or waste management system. Lot of scope towards waste management system, I can say. Every one of us, we have the potential and scope for our research. IoT parking system. So it will tell when to permit, when not to permit, and auto payment system. NFC is available. You can pay automatically, and you can do. It will announce you authorized zone and not authorized zone. You can look at here, not authorized, not authorized. All the authorized zones are filled. So then depending upon it, it will give either the alert to the smart city or the user or the police. So depending upon which application it suits, you need to take decision. Similarly, look at one more smart water management, water quality synthesizing. Quality of monitoring the water. Nowadays we don't have any quality monitoring. Even Hyderabad, the flood has happened. Subsequently people suffered due to infections or fever because contaminated water contamination happened, because we don't use any sensor. We don't verify the quality of the water. We just look at the cleanliness. Human only will detect the quality. No scientific way to verify the quality. Asset management. So what is the capacity of our dam? What is the population? How much is required? Something like that. Risk management, advanced water treatment and automation, water quality and quality monitoring, supply, pressure and control, leakage reduction. So advanced metering and management system. All those things together, it is related into smart water management system. Nowadays we don't have this all. Even lot of research is going on, it seems. So water utilization in the domestic level and in the industrial level, consumption of every family pattern, they are trying to study. This research is going on. Once everything is perfect, then people may go for automation also. Water metering, like how gas metering, how this electricity meter is available, water meter also shortly going. So street light, so it needs to look at here, street light alone use case, weather suit, barometer, 12 o'clock, I need to rush up. So just focus on this and understand, because other aspects also I wanted to discuss with you related to data storage. That is also another big domain involved with this. Smart parking system. So lane, what to say, that outer ring road, everywhere lanes are there. Every lane certain speed is there. Beyond that speed, if we operate our vehicle, automatically it will capture that number plate of the vehicle, and it will be intimated to here in the Hyderabad it is available. So they will be penalizing. There are several, maybe 3 to 4 times. Then after that they will be seizing the vehicle and disqualifying something. Some method is available here. I don't have car, so I don't bother about that. So temperature sensor, the moment temperature sensor, if you want to buy itself, please understand this. What is a range? Say minus 250 to plus 750, minus 100 to 500. That range of the data also you need to understand which country you are living. Tropical country it is different, cold country it is different. That all you need to understand what is the range of data you want to use for your country or your application. So that kind of sensor we need to. Accuracy, linearity, non-linear, linearity, because every sensor, the signal which is sensing need to be converted into electric signal, that is digital modulation. So by that time, a lot of loss of information will happen. So the signal which comes is non-linearity. Linearity conversion is another technique available with all the hardware. So you can read that. It is out of my scope. Electronics guys knows better than me. I belong to computer science. So sensitivity, circuitry, power consumption, cost, all together you need to take decision. One sensor I have brought in. Similarly, what application, what sensor you require, you need to have like this. Then you need to take decision. How the process is happening? Sensor, processing, output or actuator. This is how IoT works. So edge computing, look at a fog node. So every end nearby the device, there is a router, there is a device for processing. So nowadays, BeagleBone, Cisco, these Google, these guys are coming with a lot of fog devices. So that device you can purchase and you can install. It will take care of automatically all the communication strategies. Only little bit you need to explore. You can device and fit in. So that kind of research and development is happening. Virtualization. So edge computing advantages: cloud nearer to the device, avoid data redundancy, avoid latency delay, memory space, connectivity, distributed control architecture. These are all the merits of edge computing. Look at here, this is a BeagleBone, black Beagle board. 2 edge devices are available. Google brings tensor processing unit, TPU. GPU is graphical processing unit. Google Edge, they're selling. Cisco, fog router. So nowadays we no need to sit and work in the very micro level. Everything is available. So we need to search and bring that. Capability of edge, routing, role of edge is routing, storage, processing. In simple, anyone ask you for edge computing, it does 3 tasks: routing, storage, and processing. Cloud charge will be in crores. Edge devices are in lakhs. So decide whether you want to invest crores together or lakhs together for your infrastructure. So coming to data warehouse, 80s people use data warehouse, 11 people use data lake. Now 2020 lake house. No picture has taken internet after 2020. Nobody created. So that I am using only data lake. We supposed to use lake house in the recent scenario. What is the difference? Look at external data, operational data, extract, transform, load, ETL operation, data mart is processed data based on the requirements. It will be created the data mart. One is for user, for example, customer care. One data is for business. One data is for inventory control, something like that. Then business intelligence and reports are taken out. Data lake is what? Look at the moment data lake, when they coined the name is, the data will become a different nature, flat file, audio, video, all the text data, all the data together flooding. So that is data lake. Nowadays, WhatsApp, imagine what type of data you are sending. I am sending all the type of data we are sending. So ETL, data processing and validation. ETL filters the data requirement for the suitability of application, data mart. So what is the difference is, if you look at the data nature, then machine learning plays a role, real-time processing, real-time database. So this is what data lake. Whenever we do multivariate data and real-time data processing, data lake. What is lakehouse? If you look at the machine learning is predominant layer. After the acquisition of data, it is sent to the machine learning. From the machine learning only, whether you want to go for streaming analytics or data science, it is not fully into the picture. The momentum started 2020. The momentum started towards lake house. So look at with the data what and all you can do, because once the hardware layer combination is ready, data acquisition is the process. With the data, you can do, this is based on Gartner report. Gartner is one of the famous study you need to update every year towards the technology. They will be giving the report visionaries, leaders in the domain next 5 years of technology. Based on that only we need to even set the curriculum. Otherwise there is no use of curriculum. Now descriptive analytics, diagnostic analytics, these two analytics for understanding the past, predictive analytics, prescriptive analytics, these two are understanding the future. Then look at this, what is it? Descriptive analytics, what happened? Diagnostic analytics, why did it happen? This is insight. Predictive analytics, what will happen? Prescriptive analytics, how can we make it happen? The moment we use prescriptive analytics, optimization, operation, research only, stochastic model only will support fully for the prescriptive analytics. Till then, stochastic model not required. Here, fully statistics and probability, descriptive analytics, diagnostic analytics, predictive analytics, people are calling these days machine learning, complete machine learning related to predictive analytics. So this is something different, prescriptive analytics. So these all four analytics only will play a role. Top level component, diverse hardware, operating system, network gateway, these all we need to take decision. On device processing, we need to understand certain amount of on device processing also. What is it? On device, what and all can happen? Sequencing, combining, validating, packaging, converting, these all will happen. Raw data need to be converted. Sensor data need to be converted into the representation format, data conversion format altogether. We need to keep it in mind. Types of IoT devices: consumer IoT device, enterprise core computing devices, industrial devices. The data will be revolving. Device metadata, information about all the details related to device ID, etc., type, date of manufacture, serial number, all those things, configuration of the device, version of the device, device state information. So whether it is active device or passive device or recording device, that such kind of telemetry data. And it starts connecting all the sensor data, raw data, command data, operational data. These are all the 5 major broad category of data stored in any IoT infrastructure. It is essential also. Functional requirement, data ingestion, aggregation, data flow, edge analytics, core analytics, business analytics. These all are the functional requirement. I said initially, now I am working through the slide. Memory options, we need to take decision. Volatile memory, non-volatile memory, and multiple time programmable memory, embedded flash memory. We need to take decision what type of memory required. Wearable IoT device. All the wearable IoT device has 2 category, NOR flash category, NAND flash category. So we need to understand what kind of wearable device we are bringing. For example, wristwatch. My husband has wristwatch. It will understand the heartbeat and the pulse and the BP. These 3 it will give. So that wearable IoT device, what kind of memory we need to use. Traditional DRAM, DDR, LPDDR. So this all we should have a fair idea. Only then we can successfully establish. Even if you buy a beagle bone, we need to understand what kind of memory is fixed in it. So how it works, that little fair idea is required. Although these vendors are supporting us, they of course they earn money, but we should have fair idea. EMM memory, IoT market is going to be driven with low cost product sensors, meters, robots, wearable devices. So EM's memory is one of the low cost memory application. That is highlight EMMC memory. UFS memory. So you need to have fair idea about UFS memory. It's a competitor of EMMS. Maybe later version people do much better that. This is useful for removable flash memory also. Data explosion. So you can't say data is streamed, exploding. YouTube data, we are linked in all the social media data, WhatsApp data, even flight services, cargo and the ship movement, all those Ola, these all data explosion, Uber. All the vehicle nowadays, even omnibus people are owning IoT tracking based on that they will give. You supposed to stand nearby this vehicle started, it will arrive in 20 minutes here, traffic is identified. All those scenarios it will be popping up to you. So 34 billion devices connected to the internet, billions are estimated to be IoT devices. Near it is going to become much more. IoT data growth, it's just a statistical report, how much in zettabyte, 79.4 zettabyte information is flooded through IoT. So this is forecasting IoT cloud, Microsoft Azure, Google Cloud, IBM Watson Cloud, AWS, Cisco, and Oracle Cloud, ThingWorks, Salesforce Cloud, Car IoT platform, ThinkSpeak, GE predicts, some more data collection platform. These all automatically will collect your IoT data with very minimal commands. So famous for academic purpose, ThinkSpeak is used, ThinkSboard is used for academic purpose. Most of the IoT demonstrations they used to give these to IoT Glue, Ignite, iXon Cloud, Blink IoT platform, Fogwing. These are all the IoT data collection platform. Open source IoT framework. Framework is much more easier for working with IoT data. Device IoT, ThinkSpeak, Mainflux, Thinger IO, Zeta, Open Remote, and Particle IO. These are all useful. IoT platforms. So what is IoT platform is it will act as a bridge. So whatever we discuss is IoT platform. What is that platform is it will act as a bridge between your device and the user, or the application layer and the hardware layer. It will act as a middleware. So that middleware or middle tier is IoT platform. So IoT platform technology, this is fair detail, this is micro level detail. IoT, this middle tier platform will take care of IoT gateway, infrastructure communication, configuration management, software update, data collection, messaging, identity management. These all together, it will take care. Connectivity and communication, it will take care. That is the final solution. Connectivity and communication, data acquisition. So now popular platforms. So these are all 2020 popular platforms. So earlier I have put little bit later, earlier. Now this is latest. Samsung Arctic Cloud, Oracle IoT, ThingWorks, so Particle, IRI Veracity. These are all IoT data scenario, connected application where we can go for IoT, smart home security, autonomous farming, wearable health monitor, smart factory, wireless inventory, ultra high speed wireless internet, biometric cyber security, shipping container, logistic tracking, and common IoT data, radio frequency identification, address unique identity, source and destination address, descriptive data for process, pervasive environmental data, and positional data, sensor data, input from manufacturing unit, state of actuators, command data to control the actuators, continuous feed from cameras, patient sensor data, that's all. So what are all the IoT data you can do? Acquisition, collect, consolidate, clean, aggregate, synchronize, actuate, analyze, predict, real-time analytics, edge analytics, store the data. So these all the data will stages will happen. Phases of data migration, it is what to say, almost we are nearing. These all comes into types of data migration tool. When you are migrating from edge computation to the cloud, cloud to cloud to cloud, then everywhere the migration and data mart, ETL tool, all together, you may need to take care of data migration. So fleet integrated, wherever the fleet is available, truck, bus, train, taxi, courier, cargo, flight, vehicle, e-governance, monitoring of vehicle, mob attack, riots. So IoT mobility data, all together fleet integrated data. This is called fleet. Types of processing, central point processing, remote location processing, these all types of processing. Edge devices and computing, we have discussed enormously on almost, I can say today my session is edge computation rather than overview of IoT. Challenges in IoT storage, so volume, veracity, online streaming processing or offline processing, all those together we need to take care. Data location, data management, cost advantage, cost predictability, analytical process, enterprise multi-tenancy, these all we need to consider whenever we go for data handling. Scalability, availability, these all we need to consider. Coming to the point, I wanted to give you a few. See, look at here, magic quadrant. So who are all rocking into the distributed file system or distributed storage system? The leader. This is Gartner report. So who are all leading corporates in it? So this will give you a clue for taking your project towards your success story. Scaling down version of IoT. So starts with the sensor, actuator, edge, fog, and data center. This is how it works. So please remember, edge first working at the sensor level is the first level, edge level, next fog level. Several edge computation together it is called fog. Then finally cloud level. So next, a typical IoT service, how it happens. So this is a flow, just a holistic picture diagram. First, identify your data need, your solution, break down your solution. This also we touched upon. Evaluate your cost and if you need data ingestion, edge analytics, device manager, system-wide analytics, dashboard. This is for reports. Finally, dashboard. You are the owner. You need to know in and out of your infrastructure so that it will give complete information about your in and outflow. Business intelligence, data stream outlet. So factors you need to consider: portability, querying process, user-friendly, effectiveness, size, scale, indexing technique, and migration technique, all together, archiving technique, security, cost, whether time series dedication you require, heterogeneous data or homogeneous data, process modeling and transactions, so how you do frequently or large scale, all together you need to consider. Data lifetime in different stages. If you look at data ingestion, edge analytics, fog analytics, data stream, first circle, it starts highly, this is what required. Next, business intelligent. Again, the moment you come here, streaming analytics is called hot database. Cold database is what later on you can sit and analyze. That is cold database. Hot database, whether you want hot database or cold database, how much you want, which data type you want. That is the instinct. Cost factor is. I'll show you how to identify hot database and cold database. DB ranking engine. Look at here, go here. I don't have time to walk through here. Complete ranking, relational database, key value, document, time series, graphical, what type of data you are acquiring, which database, and complete detail, ranking detail it will give, complete information it will give you. Couchbase, Vertica, Neo4j, MariaDB, all the DBs throughout the world, how many DBs are available, everything is brought to here, and it is a kind of portal. It gives a ranking and utilization and year wise and month wise also it will give. So databases, normally hot and cold. What is hot? Immediate decision you need to take and analyze, you need to store. If missing of data happens, something goes. See, medical application, completely hot database. You need to store and you need to preserve and you need to analyze quickly. Only then you can take decision upon patients, especially ICU ward. So long-term cold database. After a month, you can sit and analyze. After a day, after a week, after a couple of hours, that is cold database. Okay, hard database. RAM is a choice for hard database. In-memory database is the choice of delivering the quickest solution and precise solution. Cold database, all the historical data, it can be anything. NoSQL DB or SQL DB. So these are all query capabilities. Just to walk through which are all the data type for what. Influx is for maximum time series database. Influx only, most of the time IoT related application is useful. Influx DB, just keep remembering, it is developed using Go programming language. Another recent popular hot cake of the day is Go programming language. Anyone becomes versatile in Go, your minimum salary package is 1 lakh per month. Go programming is need of the hour. So in DB for IoT, Create DB, SQL DB. So these 3 DB you can use it for IoT applications. MongoDB, if you wish, camera level applications, all the high-end data, audio data, video data, image data, MongoDB you can use. Rethink DB. So some DB I wanted to walk through. MySQL tutorial. I'm giving some of the URLs for further reading. Thank you so much for giving me an opportunity and listening to me. This is what my contact detail. I'll put this slide and I'll move on to the chat window. If you have any questions, you are welcome to interact with me. Only attendance feedback only always, wherever I go, attendance feedback is the only message I can. I don't know whether they are attending or not also, we cannot identify. Yeah. Yeah, host or moderator, anyone is there? I'm winding up the session. My part is over.
Yes, ma'am. I can hear you,
Yes,
ma'am.
sir. Yes, sir. Yes, sir.
That you are passing the YouTube live streaming now.
Okay, sir. Is there any
As you
question
told,
at
ma'am.
YouTube end, sir? Is there any question at YouTube end or interactions happening at YouTube end?
No, not in normal.
Okay, sir. Fine.
Still no, nobody has been.
Okay, sir.
Okay, ma'am, I haven't passed the YouTube live streaming, ma'am. So, dear participants, if you have any questions or queries, you can ask madam. Ma'am will do the response. And tomorrow morning also, as per schedule, ma'am will take the IoT using Tinkercad in virtual platform.
Hands-on.
So it will be a very interesting topic. So even though if you have any doubts in today's session also, you can able to ask tomorrow. It's also because there are another chances available. You can utilize that. So further, you need any help? Ma'am is given the number and mail ID and everything. You can able to contact them about research work or maybe whatever maybe.
Yes, sir. I think if at all they have question, this is a scope for once again interacting with them. Tomorrow I can communicate with them if at all they have. Yeah, with that note,
Yes,
thank you
yes,
for
ma'am.
today's session, listening and taking part in the session. And thank you for the organizing for giving me opportunity. Tomorrow I'll be meeting again with a Tinkercad hands-on session with the LED bulb, glow, buzzer, a few projects, how we can do with the Arduino kit. So completely it is centric to Arduino because Arduino only they have imitated in the Tinkercad for virtual platform. There is no what to say, Raspberry Pi is available with virtual platform because it is processor. It is a kit, a microcontroller kit. So tomorrow we'll be going towards fully onto hands-on session. With that note, I'm concluding today's session. Thank you all. Stay safe and let us communicate tomorrow. I'm leaving from the session. Thank you, sir.
Thank you, ma'am. Thank you. Thanks a lot for your information.
Thank you, ma'am.
Thanks a lot, ma'am.
Very good waiting for
Take care,
tomorrow session, ma'am. Thank you, ma'am. Participants, please fill the feedback. The feedback will be provided on your chat box. Closes around 12:25, and the next session will be starting exactly at 2 p.m. So don't make any delay. And some of the participants are going outside in the middle of the program, and they are joining whenever they need. So it will not be encouraged. So if you are gone outside, I will be giving you 2 chances only. After that, we will be removed from the meeting. Okay, because we are concentrating only on the proper channel because it's the AICTE sponsored. So there all the sessions are recorded and they are YouTube. So everybody is watching now. So I cannot able to provide the feedback link out of the Google Meet. So attend all the sessions. We have asked many experts. We have been called many experts because of your gaining knowledge only. So please take care of the meet. Please maintain the decorum. So the meet link will be.
Hope to see you all in the next session. Thank you. Take care.
The feedback will be up to 12:25. Then the session will be closed. Fill the feedback form. You can left out of the meeting.